Now we have the function y equals integer of x, which is defined to be the greatest integer which is less than or equal to x. Now, if x is 3.7, what's the greatest integer that's less than or equal to 3.7? Well, clearly, that's going to be 3. Integers go, -5, -4, up through -0, and then 1, 2, 3, 4. The biggest one of those that's less than or equal to 3.7 is 3. Now, what's the greatest integer less than -2.9? Don't look at the answer, think about it. Okay, well, the integers go -5, -4, -3, -2, -1. Okay, -5 is certainly less than -2.9, so is -4. And -3 is less than 2.9. But what about -2? Well, -2 less than -2.9 ain't so. -2 is greater than 2.9. So, we can't, that's, -2 isn't a candidate. -3 is the greatest integer that's less than or equal to -2.9. And you can draw those numbers on the number line, and it becomes even more clear. If this is the number line, and here's -3, -1, -2, -3, -2.9 is between -2 and -3, so -2.9 is clearly to the right of -3, so it is greater than -3. It's not less than or equal to -3. Okay, well, if we think about what this means, okay, any number. Well, let's just think of one more thing. Okay, what about 4? Is 4 less than or equal to 4? Okay. What's the greatest integer is less than or equal to 4? Well, certainly 3 is less than or equal to 4. What about 4? Well, yeah, this says less than or equal, so any integer is less than or equal to itself. 4 is certainly less than or equal to 4. So if x was 4, so there's 1, 2, 3, 4. The greatest integer would not be 3, it would be 4. So at x equals 4, the greatest integer would be 4, giving us this point on the graph directly above x equals 4. And the point here, the point 4, 3 would not be on that graph. Now let's see how that works with all the other conditions. Okay, so let's say we have the number 1. Well, 1 is less than or equal to itself, so the point 1, 1 is on the graph. And let's exaggerate the size of the closed dot here. Now, all the way from x equals 1 to x equals 2, like at x equals 1.1, x equals 1.2, the greatest integer less than or equal to, say, 1.2 is clearly still 1. And it stays that way right up to the point where we reach x equals 2. X equals 1.999999999 a million times 9s, okay, is still less than 2. So the greatest integer in that number would still be just 1, okay? But as soon as we hit 2, we jump up here, because the greatest integer in 2, greatest integer less than or equal to 2, the greatest integer function of 2 is 2. Okay, well, that's not too hard to understand. The greatest integer stays the same till we get right to the next integer, and then as soon as we get the next integer, we jump up to the next value. So between 2 and 3, the greatest integer is always 2, so the graph will just remain horizontal. Right up to that point, then it jumps up to 3, and then it remains the same until we hit 4 and jumps up to 4, and so forth. And you can see then that the greatest integer function is going to have a graph that looks like this. Okay, well, that's the graph of the greatest integer function. And you can read, of course, what the text says. You can Google this, you can do whatever, and get more explanation. But if you think it through, you understand that that's the way the graph is going to work. Now, what about, excuse me, y equals 2 times the greatest integer function of x? Well, that means is, what that means is you find the greatest integer of x, which is just the value given by this graph. So right here is the graph of the greatest integer, but now you're going to double it. Okay, well, what does that do? Well, between 1 and 2, the greatest integer has value 1. If you do 2 times the greatest integer, between 1 and 2, the value is going to be 2. So instead of having 1 between here and here, you have the value y equals 2 between here and here. Then between x equals 2 and 3, you're going to have y equals 4, double the value of the greatest integer, which would be 2. So you double 2, you get 4. So this graph is nothing but a vertical stretch of this graph. Every point moves twice as far from the x-axis, which is what happens when you double the value of any function. So here's the graph of 2 times the greatest integer of x. And you might think about what would the graph of the greatest integer of 2x be? Just something to think about, something you might encounter in the homework.